Exceptions form an important aspect of the API of a function. Callers of a function need to know which exceptions to expect under various conditions so that they can ensure appropriate exception handlers are in place. We'll use square root finding as an example, using a homegrown square root function courtesy of Heron of Alexandria, although he probably didn't use Python. Place the following code in a file called roots.py. There's only one language feature in this program we haven't met before, the logical AND operator, which we use in this case to test that two conditions are true on each iteration of the loop. Python also includes a logical OR operator, which can be used to test whether either or both operands are true. Running our program, we can see that Heron was really onto something. Let's add a new line to the main function which takes the square root of -1. If we run that, we get a new exception. What has happened is that Python has intercepted a division by 0, which occurs on the second iteration of the loop, and raised an exception, a 0 division error. Let's modify our code to catch the exception before it propagates up to the top of the call stack, thereby causing our program to stop, using the try except construct. Now when we run the script, we see that we're handling the exception cleanly. We should be careful to avoid a beginner's mistake of having too tight scopes for exception handling blocks. We can easily use one try except block for all of our calls to square root. We also need a third print statement to show how execution of the enclosed block is terminated. This is an improvement on what we started with, but most likely users of a square root function don't expect it to throw a 0 division error. Python provides us with several standard exception types to signal common errors. If a function parameter is supplied with an illegal value, it is customary to raise a value error. We can do this by using the raise keyword with a newly created exception object, which we can create by calling the value error constructor. There are two places we could deal with the division by 0. The first approach would be to wrap the root finding while loop in a try except 0 division error construct and then raise a new value error exception from inside the exception handler. This would be wasteful though. We know this routine will fail with negative numbers, so we can detect this precondition early on and raise an exception at that point. This is a simple if statement and a call to raise, passing the new exception object. The value error constructor accepts an error message. See how we also modify the docstring to make it plain which exception type will be raised by square root and under what circumstances. But look what happens if we run the program. We're still getting a traceback and an ungraceful program exit. This happens because we forgot to modify our exception handler to catch value error rather than 0 division error. Let's modify our calling code to catch the right exception class and also assign the caught exception object to a named variable so we can interrogate it after it has been caught. In this case, our interrogation is simply to print the exception object, which knows how to display itself as the message to standard error. Running the program again, we can see that our exception is being handled gracefully.